Alrighty, now it is on to question 5. Yes, okay. So now, so this one is where we have a definition of C. We're going to set C equal to some kind of collection, and then we're going to set X equal to something, and then we're going to say to you, what is C if we print it out, and what is X if we print it out. And luckily, we didn't make you write stuff in this column, because sometimes we do that, and it's, like, super tricky. Sorry that, like, we don't have a blank exam of this one. Like, the link, like, doesn't work or something. Maybe I should, like, get that fixed. But, yeah, so, just try to not look at the answers as we're doing it. Okay, so, if we do this first one. Okay, how about I just show these two columns, and then we'll pretend the other ones aren't there, and then, oh, well, they give you some of them. Why don't we give you some of them? You could do this. Okay. Well, so let's just hide those two. We're gonna print out. We're gonna see what C and what X print by not looking over there because I don't want you to see the answers. Okay. So I don't want myself to see the answers because then I don't want to cheat. So basically, first we got a C is a list of 1, 2, 3, and then we're going to set X equal to C0. So if we print out what C is, then C is just going to be that list of 1, 2, 3. Or how about I write them in the boxes? That'll be fun. So how about we do, yeah. So we're going to do, so C is still going to be 1, 2, 3. And then X is going to be the first element of C. So this is going to be 0. Wait, sorry, this is going to be 1. Guys, if we go over here, the indexes of these are 0 and 1 and 2, and we're going to index the first one, so we're going to get 1 there. And you don't even have to answer this one, but yeah, so we got 1, 2, 3, and we got 1. Cool. So now, let's go to the next one. So we were tricky with append here. Okay, so after we append, so we're going to set X equal to what C.append1 returns. So when you think of a function, sometimes it can be helpful to think, like, what is the answer? What is the result of, well, that's not even helpful in this instance, but basically, like this is going to append 1 to the list, and then what's the answer? Like, why would it, it's not going to return the list. Like, it might seem like that, but, like, it's not going to return the list, because it's just going to append to the list. Like, there's no answer to that. Maybe he returns the length or the list, or that's weird. So it's actually just not return anything. We actually test that out if I come over to, oh, that's not it. I meant to go to my remote desktop. Let's play around with this. So, let's see. I made my passcode 111111 for the video. There we go. So yeah, let's just play around with this. Yeah, so we have X is equal to a list of 1, 2, 3, 4. If we do Y is the result of X dot appending. Maybe I can. Oh, I literally wrote appending. That's embarrassing. Maybe I can make this bigger. There we go. So X dot append. We're gonna append pizza because we can do that, right? So okay, so X got appended. But Y is, we print out what Y is, because the terminal doesn't show nuns, just so you know. So that's good, yeah, it's good. So print Y gives us none. Because the result of appending, what append returns, I guess the easy way to remember it instead of my crazy way, is append returns none every time. Just remember that. Append returns none. Let's just to make this extra simple, let's go to the, let's go to the, so we're going to the, sorry, I'm trying to find the review page, and I'm just not knowing I'm doing. So let's look at all these. I'm going to say it right now so you know what these are. So this returns something, right? Because that's going to do, like, element in list. That's going to, like, evaluate. Well, it's not going to return. It's not a function. It's going to evaluate the true or false. Append does not return something. No way. Can I write on here? I don't think I can. Dang. This will not return something. Insert will not return something. It just inserts it. How about I test these out as I go to make sure I'm not saying something wrong. So how about we say print. We're going to print x dot insert. We're going to insert the value pizza at index, or wait, the index is the first one. Okay, remember that. So at index 2, we want to insert, we're going to put pizza in here. Let's put popcorn in here. want to insert popcorn. Oh, well, it turns none, right? But X got inserted. We put popcorn index at 0, 1, 2, right? But yeah, so insert returns none. Append returns none. Remove also returns none. So remember, remove is the value, not the index. So we're going to so we have this X here. Let's do X dot remove popcorn. It will remove the first one it finds, I believe. So if we so I'm going to print out what this returns. I forget the command to go to the end of the line, so I gotta do this. There we go. So that returns none. So append returns none, insert returns none, remove returns none, pop does return something, right? Because that pops the index. Let's go into, so if I pop, let's see, so if we print x.pop, pop, remember you have to put an index, so if I put pizza here, this isn't gonna work. I have to put the index, so pizza's at 0, 1, 2, 3, 4. So if we pop 4, that will give us pizza, so that does return something. So append returns none, insert returns none, remove returns none, pop returns the thing you did, sort returns none. Let's prove that. So if I do x.sort, and I print out what this is. Oh, I should have put this fancy at the end. There we go. Print sort returns none, because it just sorts the list, right? So if I do x.reverse, that also returns none, see? So if I do print x.sort, x got sorted, even though I didn't even show it, that was reversed there. So that sorts it and returns none. So again, append returns none, insert returns none, remove returns none, pop returns something that you did, or it returns the thing that you popped. Sort does not return anything, it just sorts it. Index, that will return something, right? Because we're going to get the index of an element, right? So so you can kind of think, like, is this giving me an answer, right? So let's see, I want to get the index of 2, so x.index. And in JavaScript, I think this is index of. Index 2, this is going to give me it's at index 0, 1, right? Yeah. And so that does, so this did return something, so I guess I could, in the terminal, it shows you what it returns. But yeah. So anyway, so this is a slice. This will not only return something, this will return a copy of the list. So if I do x from 0 to 1,000,000, because you can just go out of bounds on slices, who cares? So that will give me a different thing that isn't x list. If I do this is x, no it's not, even though it looks like it. Yeah, so, sorry, super huge tangent. I don't even know what we were doing. What were we doing? Yeah, we were doing this one. Yeah, so remember, so basically, almost all of the list methods are going to return none, but like, the string ones all return something, I think, because this does like, true or false, concatenates, strips stuff, splits stuff, splitting on something, yeah, and then finding will return -1 if it doesn't find it, right? So this is going to all, so these all return something. Some of these do, like this one, and this one, and this one, and this one, those return something, and these, yeah, those return something. But like, so yeah, just remember which ones return none. You can do it by playing around in this thing. Remember, you always have the console in PyCharm. If you don't know how to use that, you can come down here, this console down here at the bottom there. Oh, is my whole screen not even on the screen? Oh, but you can see things. Okay. So, yeah. Well, could you see these when I was, like, scrolling there? Hopefully. All right, anyway. So, we got off track. Let's go back. So let's see. We have a list. Whew. Now we're going to append 1 to this list. So now, let's think about what C is. C is going to be 1, 2, 3, and then 1, because we appended a 1. X is going to equal none, because this returns none every single time. So if we look over here, we have 1, 2, 3, 1, and we have none. Good job. So, am I telling myself good job? What am I doing? Okay, so this is the best. All right, so now we're going to do this one. So we got a list of a bunch of strings. And then, oh boy. So now we're going to index, we're going to get the second index. So remember, 0, 1, 2. So we're going to get the second index of C, and we're going to get the first letter, oh my goodness, 0, 1, the first letter of that string. So that is the first, so that the second, there we go. Second index, so 0, 1, 2, or actually third index, whatever. Third index of C, first letter of that because remember you index strings, that does things like that. So this is going to, so X is going to be the character 0. Oh my god, what am I doing? The character E. Sorry, I'm just asleep or something. Alright, so we got the character E, because that's the first letter of that. And then C, what did C do? Well, C didn't change, so C is just gonna still be C equals, I don't want to write all that, I'm just gonna circle this. Is that cool? So C is not changed. So let's see. C looks like it's not changed. We have A, B, C, D, and E, F. And then we printed X, that will be the character E. Remember when print, when print, prints, it removes the quotes. I hope I don't have to tell you that. So 1, 1, 1, 1, 1, 1. So if I print hello world, there's no quotes there. I think you know that. Whatever. All right. So now going on to the next one. Oh, this is tricky. So we got slicing here and like a fake list. This is a string. That's not a list. So like this slicing is not gonna do like actual slicing, right? So all right. So we got these letters here. What are these? Let's write out these indexes. So this is a string, right? So how about we say this is 0, 1, 2, 3, 4. I messed up. So 4, 5, 6, 7, 8. That's it. 0, 1, 2, 3, 4, 5, 6, 7, 8. Good. Okay. So now we have the string of 8 characters, and we're going to get from the first index, so from index 1 up to and not including, that's not a word, what, including 3. So remember, every time that you slice, you go up to and not including. That's also the case with range. Let's play around with that some more. I keep having to do this. 1, 1, 1, 1, 1, 1. All right. So if we do, let's do a string that will make like lovely indexes. So this will go up to 9. So if I do, let's do X from 3 up to and not including 5. That does not give us 5. It does from 3 to 4. If we do 3 up to and not including 3, that will not give us 3 because it does not include 3. If we do X up to and not including a bunch of things, yeah, we can go way out of bounds. Who cares? Yeah, so that will give us 3 until the end. You can also do 3 until the end with nothing there. That will give us 3 until the end. I don't know if that works. Yeah, that works. Oh, this is tricky. So this goes 3 up to and not including the last one. So that doesn't go to the end because that does up to and not including. See, that can trip you up every time. You gotta remember, like, it's up to and not including. So we could do up to and not including the last one steps of 2. That will give us 3, and then what the heck? Wait. So this starts at index 3. Wait, hold. So this starts at index 3, going steps of 2 up to, and why does that not have 5 in it? Okay, I'll think about that later. Something's going on. Okay, yeah. So if we go back to this, so this gives us from the index 1 up to and not including 3. Oh yeah, the other thing I wanted to do was I wanted to show you that. Where did my thing go? So this also works with range. So you can view ranges by listing them, just so you know. So if I do list, am I even recording? Hold on. Yes, I am. Okay, I thought I was just talking to myself. Okay, so list range of, so we do 1 to 10 steps of 2. That will give us, oh, that's why that other one wasn't working, because that's not steps of 2. I'm sorry. So this goes, so just because I wanted, like, this was a weird one. So this is doing 3, wait, okay, I gotta think about this some more. Something's going on here. 3, oh, so, okay, I confused myself. This is going from index 3 to -2 steps to -1. That's not what I wanted to do. I wanted to do this. Sorry, I got confused. Okay, anyway, so what I was gonna say is that ranges can do, so we can do from 2 to 10, 2 up to and not including 10. So it's going to do up to and not including. So basically, whenever you have 2 numbers, it's doing like a range, like in whether it's a slice like this or whether it's a range like this. Those are always going to be up to and not including the upper bound. So I'm sure you already know that, and I just like shouted at you like 20 times. I'm sorry. I'm just so we're doing from index 1 up to and not including index 3. All right. So now we're going to do from index 1 up to and not including 3. There we go. So we're going to slice that out. So this is going to be, so now, so C is not going to be modified by this because slicing never modifies a list unless you said like C equals slicing thing. So C is going to be the same, and then X is going to equal 1 comma. Like not 1 comma, like character 1, character comma, in quotes. So let's just take a look. So this is not modified. Cool. And this is 1 comma. Cool. All right. Now we're on to the next one. We got the same thing, little fake list right here. Not even a real list, fake list. Oh, we got 2 lines of code now. Okay. So this is saying C equals C dot split on comma. So the way I always like to think of split is it kind of takes whatever you're splitting on. So we're splitting on commas, and it turns them into commas. I think, well, I guess they're already commas, but I think of it as like it turns into real commas. So like if this was a list, like this is going to now be a list of 31, 2, 92, 6. So like I think of it as like turning what you're splitting on into commas. So if these were underscores, like they'd be commas. If you have 2 commas next to each other, those turn into actual commas. You'd have a list of like an empty string there. Play around with that just so you can see how that works. Or maybe I should just stop making me do this. 1, 1, 1, 1, 1, 1. I can just show you here, like, so if I was doing, like, A underscore, B underscore, C underscore, like, if I did this dot split on the underscores, that would basically turn those into commas, and, like, if we had 2 underscores next to each other, if you think of those as both being commas, there's, like, nothing between them, so I think that's kind of helpful for thinking that, but, yeah, so C is now, we made C be this list. I'm just going to leave it like that so we can see that's our answer for, so this is our answer for C because we're splitting that. We can see that C is not modified anywhere else. Oh, yes it is with remove, just kidding. So now we're going to set X equals to what C dot remove turns. From earlier in this video, does remove return anything? No, right? It totally doesn't. All right, so we're going to remove the string 2. Just quick thing, I don't even remember. So if we try to remove something that isn't in a list, what does that do? X dot remove, I think it errors 2. Oh, no it doesn't. Oh, the 2 was in the list, sorry. So X dot remove 2. Yeah, so we get an error, we say that list is not in the list. Yeah, it's not in the list. So just care for that, but it totally is in the list in this case. And it even tells you up here that no rows will produce an error. So we split on the comma. So C equals C dot split on the comma. And then we're setting X equal to what remove returns. So we immediately know, okay, you know what? X is definitely none. And then C is going to be this list, but like we removed the 2. So we gotta remove it. So C is going to equal, so 31 to, or sorry, we just removed 2, right? So 31, hold on. Wait, oh yeah, sorry, I was thinking, wait a second, this is a string, can't remove it. We turned it into a list. Okay, so this is going to be C equals, so this is kind of annoying because like these are like, so remember, we split on comma, but we didn't cast these, so these are still strings. So we gotta do 31 in quotes, and then 92 in quotes, and then 6 in quotes. And the reason, like, so see, we removed the string 2, not the number 2, so we didn't cast them yet, so we gotta, like, still put the quotes there. So let's see if we got it right. So we did 31, 92, and 6 in quotes. Good. And none. Cool. So that's those. And then, okay. So now, one thing I wanted to say, for fun, sense review purposes, I know I'm just like throwing random stuff in here. You're probably like, I just want to like, well, I mean, you could just look up the answers anyways. So like, anyway, let's make a list. I want to say, what happens if, what if I do X dot remove 2? What will X be? Think about that. So I believe, so remember this didn't return anything, see I didn't get a return there. So it will remove the first one it sees, right? So it's not going to remove the second one. So if you want to remove all of the 2s, so if I have a bunch of other numbers, I want to remove all the 2s from here. The way you'd have to do this, you'd have to say while 2 2 in x. X dot remove 2. There we go. You could also, if you want to be super cool, you could do one of these annoying things where you say like, give me x, or no, I for I in x if I is, doesn't equal 2. Don't ever do this on an exam, but that's cool. Look these up. These are called list comprehensions. Those are super cool. And I'm not supposed to mention them ever, but sorry, there you go. So now on to the last one. So this is, so we got a dictionary where, so I hate this notation, so I'm going to write this in a cooler way. I would recommend doing this on the exam too, because like this is annoying to see. So we have 2 maps to 1.2. We have 6 maps to A. Is that right? 2, 1.2, and 6A. Cool. So now, so we're going to set the second element of, sorry. So we're going to set C of 2. So this the value at C2, the key 2. We're going to add 2 to it. So we're going to plus equal 2 to that. So so think about, does this work? So we, well, you know it works because it says that no makes things make error. But think, so we take, we're going to take this value, or so we looked up this key 2 right there. So look up 2, and we're going to add 2 to this values because we're saying C of 2 plus equals 2. So yeah. So now C of 2 plus equals 2. So now this is going to be 3.2. 3.2. Because remember, if you add integer to a float, it stays a float, yeah, kind of thing. Yeah. So we added 2 to that, and now we're setting x is the length of c dot items. Okay, so remember, we got 3 things on our topics list. 1, 1, 1, 1, 1, 1. So yeah, we got 3 things on our topics list. So we have items. These. So we got keys, we got values, we got items. Remember what these do? So I'm gonna make a dictionary real quick. D equals empty dictionary. D of 1 equals 5. D of 2 equal. You know, I always like to use this example, so I say D of pi is 3.14, and D of E. What is E? Is it like 2.68 or something like that? I hope I don't get this wrong. 2.68 or something like that. So E, whatever it is. This isn't calculus. This is computer science. So yeah. So now we got this dictionary here. We got 2 values just like that. So D dot items. So this is going to basically give it. So all of these things. Let's just do them all real quick. Values and keys. They give you kind of lists, like I think of them as like sort of lists, but not really. Like you can't like do all the things you can do. So if we say, you know, what is this thing? D dot items. If I do type of D dot items, so it gives us. It says it's a dict items thing. Well, so it's kind of like a list. Like you can for loop over it, and you can take the I think you can take the length of it. Well, the length function just does a for loop and adds a error. So you can for loop over it, but you can't do things like d.items 0. You can't do this. And don't even be like, oh, I could like cast it to a list and then do it. Well, dictionaries don't have order. That's the biggest thing to remember. Is like there is no first element because there is no order. So like don't do that either. So think of them as weird lists. You can for loop over through them. If you really wanted to make it a list, you could list them all out. But usually that's not a good idea because they're kind of just getting it in a random order because dictionaries don't have order. But yeah, anyway, how's my battery doing? Hold on. Am I still recording? Yes. Cool. So anyway. So these return weird list things. All 3 of these, keys, values, and items, they return weird list things. What kind of weird list things? So keys kind of gives you all the keys. You usually never ever even need to use this because like, if you wanted to say is pi in the dictionary, you could just say pi in D. You don't really need to do in the keys because like you just check the dictionary. You could also maybe you want to get the length of how many keys are in the dictionary. Sure, you could do length of D dot keys, but you can also just do the length of the dictionary. So usually there isn't any reason to use these, but they're there. You have to know them, I guess. But yeah, and then so D dot values. So this gives us all the values. So remember in our dictionary we had these were our keys, and these are all the values. This gives us all the values. If you just want to get all the values of the list for some reason, there's some applications for this. Like I don't know, like if you, I don't know, there's uses for these. Oh yeah, if you want to be like, what are all the numbers in my dictionary? There you go. Yeah. And then so then items kind of gives you like a list of it's kind of hard to see, so maybe I will take a list of underscore is the last one. Don't forget that. Oh yeah, so basically like so this is going to be so basically items is like a bunch of tuples. So it's a list. This is so annoying. This is a list thingy of tuple pairs. We don't even teach you tuples. The tuples are because okay. So since you can index it, I could do for weird thing in D dot items. Let's print what the type of the thing is. This is going to be, you can see that they're tuples, and tuples are even their own sort of thing. So tuples are like weird lists that you can't modify. Like I can't say this 0 equals 3. You can't do that. I will say tuple does not support item assignment. Anyway, this is way off track, but anyway, so you have to, so we don't teach you tuples, but you have to know items. That is strange. Okay, so items, what I would think of it as is it's a weird list thingy of pairs where each pair, the first one is going to be the key and the second is going to be the value. And you probably learned this. I'm just going over anyway. Yeah, and that's weird because we don't teach you tuples. We have to learn this anyway. It's a list thingy of pairs. It's a list-like thing of pairs where the first thing in the pair is the key and the second one's the value. It's super annoying. You can do kind of cool things with this. You could say, I wouldn't recommend this actually, but you could say for key comma value in D.items. Sorry, forgot my colon. Oh, man, I messed it up. Hold on. So for key, comma value in D, comma items, you could say print key equals value. You could do it like this. So I usually wouldn't recommend that because you could just instead say it's probably a little simpler actually to say for key in D, print key comma D key. That does the same thing. Probably easier. Sometimes it's just kind of fun to do this syntax there. Anyway, we are super off track. My point with all this was just to go over what items was. So items is a list. Basically, you could think of it as a list thingy of the pairs of, or maybe you could think of it as a set, like a set of pairs, even though it's not a set, but it's like a set of pairs. So how many like pairs of keys and values do we have? Well, we have one pair. We have two pairs. This is going to be 2, so this is going to be x is 2. Items does not modify C, so don't worry about that. So what is C now at the end of all this? So C equals, I'm going to use this annoying syntax, 2 is now 3.2, and 6 is still A. So now let's see if we got this right. So we got 2 is 3.2, and 6 is A. Cool. And X is 2. All right. There we go. There is question 5. If you have any questions about this, you can leave them in the comments.